Welcome to Hints and Tips on using and cleaning up Excel and CSV files as a data source for use in ArcGIS Pro. This is actually a two-part module. This is part one of the two-part module. It's brought to you through funding from the National Science Foundation to the National Geospatial Center of Excellence, or Geotech Center. I'm Ann Johnson, and if you have any questions or comments, please do contact me at my email address. We're going to look at both Excel and those comma-separated values, or CSV files, and look at how we can clean them up and use them in ArcGIS Pro. The part one will focus on cleaning up those data and common methods. I'm not going to go into all of the techniques you can use in Excel because not all of them really apply to use of data in ArcGIS Pro. There are different versions of Excel and CSV, so be aware that you may have slightly different methods. Part two will focus on methods to really update the tables that are best done in or within or as you load it into, import it into ArcGIS Pro. So there's a lot of data out on the internet and other places, and this happens to be one of the data tables from the United States Census Bureau, and it's got some great information. It has descriptive titles, and it helps you understand what each of these columns mean, and I can see that it's by state, so all the states are listed, and then there are different categories within the overall percent. So it's showing you the units. But really, to use this data in ArcGIS Pro, you'd have to bring it in and clean it up to put it into the format that you would need. So here's a data set as a comma-separated values, or CSV file, and it's also from the U.S. Census Bureau, and it has 151 columns or fields of data. So I'm going to be talking about fields or columns, and here they're numbered or lettered from A to Z, and then it goes AA to AZ and BA to BZ, and continuing for 151 columns or fields. There are also rows of data, and rows are numbered, and in this instance they're all states plus the District of Columbia, and they go from rows 1 to row 59. Row 1 is the header row, and we'll talk about header rows and what kind of data has to be within those row numbers. And then there are cells, and we'll talk about cells. So just know that each cell has got a row letter and a row number, and this happens to be cell B13. Field headings are abbreviations, and they need to have definitions. And the USGS maintains a very extensive data dictionary. So you can see where those titles on this were not descriptive like the first table I showed you, but really need a data dictionary. We're going to look at using Excel worksheets in ArcGIS Pro, and there are many methods to conform and update data tables that can be done in Excel before you actually have to bring it into ArcGIS Pro. So a lot of times bring in your data, look at it, make sure to change the headings for fields to ArcGIS Pro format, and we're going to talk about that is. And also, as you do these change in headings, make sure you create your data dictionary so you remember what your abbreviated headings really meant. And then take a look at the data fields, and are they numeric, text strings? And then you can add or delete fields and rows as needed before you do anything else. Also, a text string, also just known as text, is just a group of characters, and they're often just words, but they can include letters and numbers and other things. By default, text strings are left aligned in those fields, so we'll look at those, and numbers are right aligned in an Excel field cell. We're going to look at functions and tools that can be used in Excel to create data that you might not have in the original table, and how to format the rows and fields for those. Excel has hundreds, literally more than 300 different functions available, but not all of them are useful for cleaning up data or use as data sets and data tables in ArcGIS Pro. So we're going to look at the ones that are really more commonly used functions, and we'll look at some of the tools as well as the functions that are important that you may want to know about as you clean up your data. So format for the Excel worksheets, thinking about bringing it into ArcGIS Pro, remember that first row header that I showed you? Those field names, they have to start with a letter. They can only use text or numbers and no other characters except an underline. And if you use anything else, when you bring it into Pro, it's going to change it. So just when you clean it up, just think about starting your field headings, their headers, with text. Field columns should contain the same type of data. So the same columns, if you're creating data, it should be numbers or text or dates. Don't mix it up. If a cell is a field with both numbers and text, ArcGIS Pro is going to change it, and it will change everything within that field to a text. Maximum of 255 characters in a cell. And a cell may display a value, but we're going to look at some ways where there's really a formula, one of the functions within the cell itself, rather than the value, and we'll see the difference. So fields, numeric or text in Excel, may not remain the same. It does not use the Excel format that was defined when you bring it into ArcGIS Pro. And in general, it'll look at the first 8 rows and determine the field format. If you have mixed text and numbers in there, it's going to change them all and convert them to a text or a text string. Also, we're going to look at, and especially in part 2, what happens to that leading 0 in some of your fields. Zip codes come with a 0 as the first number, and it does not always persist from Excel to Pro. Note too that strings can contain only certain characters, so don't use these. And I'm not going to go through these, but you will see what they are, and just best to keep it simple. So Excel has a workbook, and a workbook can contain several worksheets. This particular example has 4 worksheets. You can see their names down at the bottom: final, change, original data, average, _3. Each worksheet has those same rows and fields of data that we showed earlier. So we're going to be talking about fields and rows. The numeric values, you'll notice, are aligned on the right side of a field column, and the text are aligned on the left. So you can pretty easily see which is text and which is a value. So look at the numbers for batting averages, and those are all aligned on the right. They're numeric. Look at first or last name. They're aligned on the left. They're text. There's 2 ways to create a copy of a worksheet, and one of them is to highlight the data and copy it, and then click on a small plus at the bottom of the worksheet, and a blank worksheet will open. So here's that little X. If you click on that, you can copy and paste the new sheet, or you can right-click on the name of the worksheet and right-click, move, or copy, and be sure to check Create a Copy box, and then click OK, and you will have a new one. I always suggest keeping the original worksheet so that you have a history of what you've done, and then be sure and put a name on the new worksheet. Right here it's just called Sheet 2. I would name it something significant. And only one worksheet is added at any point in time in ArcGIS Pro, so you can keep the Excel spreadsheets for long-term review of what you have done. So here's an example of a worksheet, and this just happens to be data that are batting averages for some players, and they were collected during the season. So batting average was the first when they started, in the middle, and the final. And the batting averages for each of the players, they want to know what their final average is, if they improved, and by how much they improved. And you'll notice that there's 3 columns there: average 3-year, change, and improvement, yes or no. So we're going to fill in those using formulas based on Visual Basic for applications using functions. So we're going to look a pretty closer look at this example worksheet. So cells are referenced by their field, column, letter, and row. For example, Smith is in cell A2 and Jan is in cell B2. So keep those cells and rows in mind. So a function in Excel is a predefined formula that calculates a value that can be displayed in a cell. The empty cells in this worksheet are going to be populated using those functions. Note that the cell is going to display the formula, display the value, but will actually contain the formula. So here are some functions, and we're going to learn how to use them, copy and paste them down for the whole thing. Like I mentioned, there are over 300 functions available in Excel, but we're going to look at just some of those that are really useful for use in cleaning up data for use in ArcGIS Pro. So each function does have a name, and this particular function equals sum paren A2 to D2. It is named sum, S-U-M, and it's usually in capital letters like this. This function tells Excel to add together all values from cell A2 to D2 and display the result. A function is alerted to Excel itself by using that equal sign at the beginning. So whenever you see that equals, it's going to say this cell has not got a result in it, it has a function actually. And that function can be copied and pasted and used in other cells. And the formula will audibly be adjusted to the new row or column. So for example, if you copied sum A2 to D2 in a cell and pasted it in the row below it, so it will change the formula automatically to the sum of A3, D3. So it changes to that new row. The change is based on using relative references, and we're not going to get into relative versus absolute references, but if you're curious, do go to Microsoft Help. Column I, so that's A, B, C, D, E, F, G, H, I, needs 3 batting averages added together. And then the result divided by those 3 averages to get a final average for the year. I can use various formulas. I could use a sum one, or I can use a simple one. Here I'm using just the equals because that tells Excel that it's a function, not a value. And I can say add F2, FG, and F3 together and then divide by 3. I could also use the sum function here. I could say equals sum, and this equation F2 comma FG 2 comma H, and divide by 3, or I could write it with colons. So you can write them in various ways mathematically. Once the formula is created in the first row, it can be copied and pasted. So I just go up and say copy that function and paste it in. When I have the pasted in, it automatically takes the values from the row that that function is in rather than the initial one. So it actually automatically updates it. Here we have the change field, and it's going to ask the difference between the initial batting average for each player and the player's final average. And it's very similar to what we did before. This is a simple sum, so just sum I2 minus F2, and it gives me the change. So if it's a positive number, they increase their batting average, and if it was a negative number, they decreased the batting average. Here I want to illustrate too that before I use the copy and paste, but there is a little teeny green box on the lower right of that cell. And if you click on it and drag it down, it will automatically, it's called the fill handle, and you can click and drag down to fill in the column. So here it is. It's just really a tiny little thing. Once you have it, you can fill it in, and you can see the changes are now positive or negative. But what does that mean? Did they improve or did they not improve? So I'd like a little column that said yes or no, they improved. And I can use an if function. This function allows the user to specify what's going to happen if a value is attained or not. So the if function calculates whether a batter improved their batting average or not. And it's based on that value in J. If it's greater than a 0, so it's a positive number, it's going to put in yes. And if not, it will put in no. So in words, it says that if the values in the batter's change field is greater than 0, enter yes as a result. If not, enter no. So this is an easy way to fill in a field without having to type it each time. Again, it's a copy-paste. So here we have them, yeses and nos, whether they improved or didn't improve. Just note that if functions are pretty powerful. You can nest more than one function together, if function, and you can have multiple comparisons just using one formula. Well, I have only 11 players, and yet there are 13 data rows, so there's something wrong. And what it is there's actually maybe a duplicate, but how do I find it? Can I search through and check each one? Or there is actually a tool. It's the Remove Duplicates tool, so it's not a function, but it's a tool actually, and I can see it up here on the far right, Remove Duplicates. It tells me select which ones, and I know it's the last name, and it's duplicated. I could check other things, but I just checked last name. And the Remove Duplicates tool from up here, the little window opens, and I can tell it check the last names, and it goes through and it found 2 of them. So now I have just my original 11 players, but maybe I want to not have their first and last names separate as 2 separate columns. I may want to put them combined together in the roster as one name, John Smith or Adam Jones, rather than the last names or just the first names. I can use the concat function. So that takes 2 cells and puts it into one. You can see equals concat of B3, comma, and those 2 quotes with a space between tells it to put a space between the values, and the other value would be A3. So I'm going to take John's first name and his last name, Smith, and put it into one column. So here we have it as a function, the concat function, and it puts in the first and the last names. And again, you can copy and paste that first one and fill it in all the way down. We can also do a find and replace. I realized Schmidt should be Smith, and it may occur in your database more than one time. Here it just occurs once, and it's pretty obvious to see, but it occurs as that last one. And then it was copied into the full name concat that we had. So I'm going to use the find and replace function, and I can click on that tool, and it comes up with find and replace, find Schmidt, which was misspelled, and add the H so that it becomes Smith. So now I have John Smith rather than John Schmidt. Now I'm going to look at other functions, and I'm going to say, what if I want to have all caps, where it's showing the label, the city, in all caps, to just initial caps. And I may want to do this because I may want to label that particular person with where they live, but I don't want the map label in ArcGIS Pro to be all caps. So I can use a function that's called equal proper and then the text that I want. So this function allows me to say, take that field that says city and it's all caps and put it into a new column. You do have to use and create a new empty field for it though. So that's one difference with this one. So here I actually created a new field, field G, it's empty. I will then go in and use the equals proper text and fill it copy paste, and I now have all of my original city names that are all caps into initial caps and lowercase. Sometimes you want to transpose your fields to rows, and this can be a rather complex thing. So what we'll first do is highlight all the fields and rows and then click Control key and a capital C. So this is a little bit different too. So it's the Control key on your keyboard and the capital C. Go to a blank space in your worksheet and use paste by clicking on the transpose icon. So here's the transpose. So instead of copying and just pasting the initial in the clipboard, I'm going to actually use a paste option where it will transpose automatically those rows and columns. So here is my transposed one. I now have all of my rows as columns and all my columns as rows. And I could, then I suggest copying it as it places it in place in your initial first page into its own worksheet. So copy and paste, add a new one, and then name it with an appropriate name for that worksheet. You can also just use a simple tool. Say you've used a lot of these and we've already used several different functions. Well, which are real values and which are just formulas? So I can use the tool that says show formulas to actually show me where the formulas are and what the formulas are in those various fields. This is pretty useful. Say you may have another table and you want to use the same tool, you can see what the formula was and use it and copy and paste. So field values rather than formulas. So now I've got copy and paste the values in the original field. Maybe I really want the value and not the formula. So I can highlight it, right click it and copy, and then right click on the new field on a new field cell and paste it using values in the empty field. So instead of using the clipboard, I'm going to use copy and the values. You can see it here. It's got the 1, 2, 3 on it. That means that it's not going to use the formula. It's going to actually put the values into a new field. And I can then come over here and just paste it. So now I actually have the values rather than the formula. So if I went back up and used that tool to show formulas, those would show as values and not formulas. I can also really clean up a lot of things. A lot of times you get a lot of data. This happens to be a very extensive set of earthquakes, literally thousands, and maybe I don't need all of this data for a study that I'm doing. So I can come in here and I can do various things to clean it up. And when I look at my data under type, it says earthquake. But if I go down, I can find out that there's also different things. There's blasts and construction site earthquakes that were recorded. So I can use that field, that type field, to sort the data and remove all sources other than earthquakes. So here I would just use sort type and pick type, the cell values A to Z. So I will get all of my data with earthquakes in one apart. I can take explosions or other things and highlight them and delete them. So now all I have left is earthquakes. I can also say I don't need all of these different fields, magnitude, type. I don't even know what some of these are. I could probably look them up in a data dictionary, but I really don't need those. What I want is the date, the latitude, longitude, depth, magnitude, and earthquake. So I want to keep those. I just highlight the fields that I don't want and do a delete. So now I have a nice tight set of data, removed unneeded rows, and highlight and delete or delete full sheet fields. Setting the display of the data with numbers of decimal places is also pretty useful in Excel and in CSV files. But look at depth. I have depth to a very high precision, lots and lots of decimal places. I may not want those, so I can actually go in and use another tool to look at customs and display and just a number, and use just the number that I want of decimal places. Say I want 1 or 2 or none, and all of a sudden it makes a lot cleaner database. It's really nice. I've now got latitude and longitude with 4 decimal places. That's good. And depth to 2 decimal places, magnitude to 2 decimal places. It's really a good way to display the data. And I'm going to say displayed because when you take this Excel spreadsheet that looks really good and has only 2 decimal places, ArcGIS Pro doesn't. Maybe for my study, I don't need it down to the second. All I need is really to the date, to the day of the year, month, day, and year. So here I can use a function. It's called left. So I'm going to take A2, my cell A2, and take the left to 10 characters and copy that down. So here's the function, equals left paren A2, 10, and I can copy and paste it down into my other fields and end up with the time still remaining. I may want it for some other thing, or I may keep it, but I now have a date function that gives me the date for each of my values. Sometimes you want to create 2 fields based on the data in one field, and this can happen. This particular thing is here a column here is zip plus 4. So I have the 5-digit zip code plus its 4-digit extension. And oftentimes with a geocoder, you may have zip and the plus 4 in 2 different columns, so you need them separated. So first, to separate them into 2 columns, I'm going to highlight the field and I'm going to want to split it on a data and text to columns tool. So here it is, text to columns tool. I can convert the to text using this wizard, and it's going to give me a delimiter. Here I'm going to say, how do I want these 2 columns split? And it's going to be using a character such as commas or tabs. And luckily I do have a dash between the 5 and the 4 digits. So I'll use that as the other symbol to use, and it will say, okay, split it right here. Then say next. I now have the 2, and I want it as text, both the zip 4 and the zip 5 and the 4, and I'll say finish. I now have the zip plus 4 and the 2 columns, and I can label them. So now I have the zip and the plus 4 that I can use to in a geocoder. Often providing geographic location, you need to separate or create a key field where you have your data table that doesn't have a location in it, and you have a key field in a geodatabase that does have a location in it, and I can join those 2 together. Now, one proviso is they have to be in the same type of format, so either text or numeric. And here I have a field, the address field, that has the state address in it, and it's California. And I can actually then go in and use that right again. So I can do the formula equals right, and I'm going to look at E2 and say E2. I've got a lot of digits there, but I just want the right two things, copy, paste, and I get those two letters. I can now use that as a key field if I have a geodatabase that can show me and connect to the location of a state. So here is just looking at an example of a key field in a table that I brought in, and also one that has a shape, a polygon field for those various things. So here the key field is state. In each case they're both text, and I can join these two tables of my data together and have it present geographically. Well, is it a CVS file or an Excel file? And it's really kind of hard to tell. So on the two examples, the batting averages and the earthquakes both appeared to be Excel. But actually the batting averages was an Excel spreadsheet that I created manually. Earthquakes was one that was downloaded, copied, and pasted from the website. So one was an Excel, one was a CVS file, but I really couldn't tell. But you can actually go in and do a save as, and it will tell you what it is. You can save it as, or you can actually go in and make sure that you know which one is which. And you can look at these here, they all three look the same. The top appears to be an Excel, the middle is actually a CSV file, and the bottom one is a Excel file, yet they look very, very identical. It's hard to tell the difference. The one way I can tell the difference is, if you notice, there is on the middle and the lower one an extension, a 3-letter extension. The top one doesn't have that. Well, how do I add it? Well, if you go to your File Explorer and go in and Manage and View and check the box for File Name Extensions, it will add those 3 letters to the end of your title of your document. And then you'll know whether it's an Excel file or a CSV file. Some processing, though, is really done best after adding the tables to ArcGIS Pro. So in part 2, we're going to look at hints and tips for importing and updating data tables for use in ArcGIS Pro. Thank you, and my email address is there. Please contact me if you have any questions. Thank you.